And I'll read this again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@yvcc.edu and I will respond as soon as I can. I've actually done that all in one breath sometimes. Okay, so today, I guess I should hang on back up here. Today we're going to be covering section 6.1, which is the idea of the greatest common factor and then factoring by grouping. So we're going to start out with the idea of the greatest common factor. So let's say we have the numbers 10 and 15. Can everybody see the white screen that I'm writing on there?
Yes.
Yes, great, thank you. All right, we want to find the greatest common factor, or the GCF. Well, 10 is 2 times 5, and 15 is 3 times 5. So breaking each number down into its prime factorization, we see that both numbers have a factor of 5. So the greatest common factor equals 5. Somebody's microphone keeps going wah, wah. So if you don't need to, maybe you could mute your microphones. Paula, Yesenia, I'm not sure which one of those. There we go. Let's see. That seems to have taken care of it. Right, thanks. And then if you need to talk, you just unmute it. Okay, super. Let's say we've got the two numbers 60 and 72, and we're looking for the greatest common factor. Well, if we break 60 down into its prime factorization, this would be 2 times 30, or 2 times 2 times 15, or 2 times 2 times 3 times 5. 72 would be 2 times 36, 2 times 2 times 18, 2 times 2 times 2 times 9, 2 times 2 times 2 times 3 times 3. So we see that both numbers share a common factor of a 2. They share another common factor of a 2, and they share a common factor of a 3. So the greatest common factor is 2 times 2 times 3, or 4 times 3, or 12. So the greatest common factor of 60 and 72 is 12. Any questions on this? All right, let's go a little further into the deep end. Let's say we've got c squared and c to the 7th power. Well, if we break this down into its prime factors, this is c times c, and this is c times c times c times c times c times c times c. We see that they both share a common factor of c times c, or c squared. Well, this seems like a lot of work. We could have just looked at these and said, well, you know what? The smallest power of c is going to be the greatest common factor. That would have been a bit easier, huh? Yeah. Let's see. Let's take a look at this one. 18r and 27r cubed. Well, 18 is 2 times 9, or 2 times 3 times 3. 27 is 3 times 9, or 3 times 3 times 3. So they share a common factor of a 3, another common factor of a 3. So that would be, and then the lowest power of r is r to the 1 power. So we'd end up with 9r as our greatest common factor. Any questions on that? Okay. How about this one? 12r squared, 15rs, 9r squared s squared. Looking across the numbers, the 12, the 15, and the 9, let's see, that 3 would be the greatest common factor of the numbers. The r's, I have r squared, r, and r, so just an r. S's, I have no S's, 1 S and 2 S's. So this doesn't have any S's, so their greatest common factor is just 3r. Any questions there? All right. Suppose we've got 2 times the quantity y minus 1 and 5 times the quantity y minus 1. Well, the first number, the factors are 2 and the quantity y minus 1. The second number, the factors are 5 and the quantity y minus 1. So the greatest common factor would be y minus 1.
Makes sense.
Okay, let's say we've got 18x plus 24. Now, earlier the directions, they just wanted us to find the greatest common factor. Now it says factor out the greatest common factor. So the answer is going to look a little bit differently. Let's see, the greatest common factor would be what, 6, I think. So I'm going to factor out a 6. It's like I'm going to undistribute. So if I take a 6 out of 18x, I have 3x left. If I take a 6 out of 24, I have 4 left. So factoring out the greatest common factor, we take out the 6, and then we have these leftovers. So this would be the final answer. How do you check to know that's correct? 2 things. First of all, is there anything inside the parentheses that I didn't factor out that I could have? In this case, no. And secondly, if I multiply it back together, do I get what I started with? Yes, I do. I'm actually going to go back and do this problem again. This time I'm going to do it incorrectly just to show you what I'm talking about in terms of checking it. Well, I can see that both numbers are even, so I could take out a 2, okay? The problem is 2 is not the greatest common factor. How do I know? Because if I look at what's left here, I see that, oh, a 3 could be taken out of both of those. So I need to start over and say, okay, let's take out a 6. Okay, so even though this multiplied together would give us that, we didn't take out the largest factor of both terms. And they want us to factor out that greatest common factor. Okay. If you have any questions as we go along, feel free to stop me and say, hey, wait a minute, please, what did you do there? What happened? Okay. A squared plus 9a. It says factor out the greatest common factor. In this case, the greatest common factor is a. So the leftovers would be a plus 9. There's no common factor with a plus 9 other than just a 1, which taking it out wouldn't change anything. And if we multiply it back together, we get a squared plus 9a. So this is the correct result. Okay, let's say we've got 27a squared minus 9a plus 9. Oops, I didn't want to put that there. All right. So the greatest common factor here is a 9. Before we go on, I want to talk about Hansel and Gretel. Does anybody know the story of Hansel and Gretel? Anybody? They went into the woods and they didn't want to get lost, so they left a trail of breadcrumbs, but then the birds ate the breadcrumbs, so the kids couldn't find their way out of the woods. Nobody's ever heard that story?
Yeah.
Okay, and then they went to a house that was made of candy and all that. But anyway, okay, my point is, they had a good idea to leave a trail to find their way back. Unfortunately, they used breadcrumbs, which the birds, I can't even talk, the birds ate, okay? We need to leave a trail. And what am I talking about here? Well, if we take a 9 out, we get 3a squared minus a. People sometimes think, oh, we're done because I've got the 9, which is right there, but we need to leave a trail to get back. So we actually have to have a plus 1 there. because we have to be able to get back here through multiplying or distributing, okay? So we need that +1 there. Don't forget that trail, okay? All right, any questions on that? Let's see here. We've got 3x squared y cubed minus 9x to the 4th y cubed. So factoring out the greatest common factor would be a 3, and then x squared y cubed, that's the greatest common factor. So I'm going to get 3x squared y cubed times, oh, what do I need to put first thing? A 1, right, and then minus 3x squared. Good job, because there's nothing common here other than 1, and that would give me 3x squared y cubed minus 9x to the 4th y cubed. So this is the correct answer. Great. Okay, now, new set of directions. This says factor out -1 from each polynomial. So basically, I'm going to do that. Well, you may recall that if you distribute -1 through a group in parentheses, it changes the sign of each term inside. Well, factoring out a negative does the same thing. So this is going to be an x plus 2y. Changes the sign here and here. Because if I distributed this back together, I'd get -x minus 2y. So my answer is this. You could also write it just like that if you didn't want to put the implied 1 between the negative sign and the parentheses. All right with that? Let's take a look at another one of those. -t squared minus 9t plus 1. It says to factor out a -1. So we're going to get t squared plus 9t minus 1. Now, the reason that they're having us practice this idea is down the road here a little bit, when we have a polynomial and it has a leading term that's negative, often we're going to want to factor out a -1 to make the remainder easier to factor. Okay, let's do one more here. 7 minus 8b, that would be negative times -7 plus 8b. Or you could also write it negative times 8b minus 7, commuting the two add-ins. Okay, two terms there. All right. Let's see here, -4a squared minus 6a. We're going to factor out the greatest common factor. And since the leading term is negative, we're going to factor out a negative greatest common factor, which would be -2a. Left over, let's see, I'd have what? 2a plus 3. Here, we can move that over a little bit closer. Like that. Any questions there? All righty. This again says factor. We've got y times x plus 2 plus 3 times x plus 2. The greatest common factor would be the x plus 2. So I'm going to factor out the x plus 2, but what I've got left is y plus 3. Any questions on what I did there? Again, this was taken out and then this was left over. Let's take a look at another one of those. M times the quantity P minus Q minus 5 times the quantity P minus Q. So the greatest common factor is P minus Q, and the leftovers are M minus 5. Questions there? Okay, let's see here. New set of directions. It says factor by grouping. Okay, and we have this problem. 2x plus 2y plus ax plus ay. Now, if I look at all 4 terms, there is no greatest common factor other than just a plain old 1. And factoring out a 1, just writing 1 times all of that wouldn't really accomplish anything in this problem. What I'm going to do is I'm going to split it up into 2 groups of 2. Okay? Take a look at what's on the left side of the red squiggly line. The greatest common factor there is a 2, and the leftovers would be x plus y. Take a look at the terms on the right side of the squiggly red line. The greatest common factor would be an a with the leftovers of x plus y. Now, there's something missing. Right here, I need to put a sign. That would have to be a plus sign to make this thing equivalent to what was there before. Well, now, do you see that it looks like some of the previous problems? We would then take out an x plus y and have a 2 plus a left over. So there we've factored by grouping. Any questions on that? Tell you what, let's check our work. 2 times x is 2x. X times a would be, I'm going to write it ax, and that's going to be plus 2y plus ay. Well, let's see. 2x, yeah, 2y, ax, ay, so it checks. Okay? They weren't in the same order, but addition is commutative. Any questions there? All righty. Let's see here. 12ab minus 4ac plus 3db minus dc. Again, we're going to factor by grouping, so we'll split it up here, groups of 2. The greatest common factor of the first 2 terms is 4a, with a 3b minus c left over. The greatest common factor here is d, with a 3b minus c left over. Oh, and I need a plus sign there, don't I, to make it work? Well, let's see then. Now the greatest common factor would be 3b minus c, and the leftovers 4a plus d. Any questions there? Okay, let's see here. How about this? 6a cubed minus a squared plus 18a minus 3. Splitting that up into 2 groups of 2. The greatest common factor of the first 2 would be a squared, with a leftover of 6a minus 1. Don't forget I need that trail to get back there. Over here, the greatest common factor would be a 3, and I'd get 6a minus 1, and I need a plus sign out there. So then I've got 6a minus 1 times a squared plus 3.
Question. What exactly are you doing to that to get the answers that you're getting? Like, you know what I mean?
Okay, so first of all, I'm splitting it up into two separate groups. Okay, with two terms and then two terms. Then I'm taking each binomial, two terms, taking out the greatest common factor. Same thing here. But since these two match, I can go further, taking out the greatest common factor there and then the leftovers. So I'm taking these four terms and writing them as a single product.
Okay.
You seeing that?
Yes.
Okay, well, we're going to do some more here. So we'll either make it better or make it worse. No, hopefully we'll just make it better. Okay, so now let's say I've got xy plus 3y squared plus x plus 3y. Okay, so I'm going to split it up into two groups of two. The greatest common factor of the first two groups is y, and I've got an x plus 3y left over. The greatest common factor here is just a 1. And then I've got an x plus 3y left over and a plus sign there. Now, you might say, do I really need that 1 there? Isn't this the same thing as just that? And you'd be correct, but there's a reason why I think you should write the 1 there. And that is in the next step, that's going to be the greatest common factor, but we're going to need a y and a plus 1 right there to have a trail to get back using distributive property, the distributive property.
How do you get the 1?
Where did I get this from?
Yeah, like on the top one.
Well, isn't this the same thing as 1 times that?
Yes.
So I put that 1 out there to remind me that I need it down here so that when I distribute, I get back to there.
Okay.
All right?
Mhm.
Okay. Let's take a look at this one. Tx plus tz minus x minus z. And again, we'll split it up into two terms or two parts with two terms in each part. So the greatest common factor of the first one is t with an x plus z left over. Well, now I've got a situation. Should I factor out from here? Should I take out a 1 or a negative 1? Well, before we answer that question, let's go back a ways. Let's go all the way back to here. For me to be able to go from here to here, these two quantities had to match so that I could take out the greatest common factor. Okay? Here, these two quantities had to match so that I could take out the greatest common factor. Here, these two quantities had to match so I could take out the greatest common factor. These two quantities had to match so I could take enough already. Okay, we get the picture. Well, so what has to happen here? These two quantities have to match so that we can take out the greatest common factor. Well, if these have to match, what am I going to take out of there? Am I going to take out a plus 1 or a minus 1?
Minus 1.
A minus 1. And there you have it. Which is why I say when you're factoring by grouping, after you've done the first piece, don't look up, look over, because that needs to match that for it to work. So go ahead and put that there, copy that over there, or clone it, whatever, and then look up there and say, okay, can I make that work? Because if you can't get these two to match, you can't go any further. Let's see if we can make sense of that. So Rx plus Sx minus Ry minus Sy. So The greatest common factor of the first two terms is x, and I have an r plus s left over. So I already know for this to work, I have to have an r plus s left over. So what am I going to take out of there?
Negative y.
Negative y. Does that work? Yeah, it does. And now I can take out r plus s and have x minus y. See how that's working? This is where I assume everybody's going, yes, I'm just not hearing it.
Yes.
All right, thank you. Thank you for being the spokesperson. Okay, let's take a look at another situation. Here we have 5m cubed plus 6 plus 5m squared plus 6m. And it says factor by grouping. So here we go. We split it up into two groups. Well, the greatest common factor here is just a 1. So I'd get 1 times 5m cubed plus 6, which means I'd have to have that. That's not going to work, is it? So what I'm going to do is I'm going to take my original polynomial and I'm going to rewrite it in descending powers of the variable. So 5m cubed plus 5m squared plus 6m plus 6. Any questions about what I just did there? It's also referred to as standard form of a polynomial. It's in one variable and we write it in descending powers. So we've got m to the third, m to the second, m to the first, no m at all. Okay. So now let's try the grouping thing. Let's see, what's the greatest common factor there? Oh, 5m squared and then m plus 1. So don't look up, look over. What's going to go right there?
5m plus 1. Or m plus 1, sorry.
M plus 1. And now look up here. What do I need? I need a plus 6. So I get m plus 1, 5m squared plus 6, and we're done. Questions on that? Okay, let's look at another one here. H cubed minus 8 plus h minus 8h squared. Let's put this thing in descending power. H cubed minus 8h squared plus h minus 8. Let's break it up into two groups of 2. Greatest common factor here is h squared. So I've got h minus 8 left over, which means over here I need h minus 8. Oh, what am I going to factor out of that?
One.
Is it plus or minus?
Plus.
Okay, so now going from there, the greatest common factor is h minus 8, and the leftovers are h squared plus 1. And there we have our final answer. All righty. Let's see here. Now they just kind of mix the problems all together. So it just says factor. So what's the greatest common factor here? It would be y plus 9, and the leftovers are x minus 21. Questions there? All right. How about this one? 6x cubed minus 6x squared plus 12x minus 12. It says factor by grouping. Now, if I'm not awake, I will miss this problem in terms of the first step. Is there a greatest common factor for all 4 terms that we could take out before we do factoring by grouping?
6.
Right. So our first move would be to take the 6 out. Okay. Now I'm going to take what's inside and factor that by grouping. So I'm going to get the 6 outside. I'm going to switch to brackets instead of parentheses, and hopefully you'll see why here in a minute, because now I'm going to have what? X squared times x minus 1. Over here, I'm going to have x minus 1 and a plus 2. So then I get a 6 times x minus 1 times x squared plus 2. So look that over and see if you have any questions. If I lost you anywhere there, let me know and I'll go back and go through it again. So everybody's okay with that? All right. How about this one? 39r cubed plus 26r squared. The directions say factor. Well, there's only two terms to start with. We're not going to use factoring by grouping here, but let's see. The greatest common factor, what goes into 39 that also goes into 26?
13.
13, excellent. What goes into r cubed that also goes into r squared?
R squared.
Excellent. So now what's left? I've got 3r, because that times that would be 39r cubed, plus 2, because that would be 26r squared. So 13r squared times the quantity 3r plus 2. Let's see here. 24. If I'm ever going too fast and I go past a problem and you're not finished writing it down, let me know and I can go back to it. 24 cm minus 12 cn plus 16 c. Well, let's see, 24, 12, and 16. 2 goes into those. Oh, 4 goes in. Anything bigger than 4 in terms of numbers? I don't think so.
No.
And then what about the variables? They all contain a single c, and I think that's it. Well, let's see. 24 cm would be 4c times 6m. So there's your 24 cm. And then minus 12 cn, that would be, let's see, minus 3n. That would be minus 12 cn. And then plus 16c plus 4 would give you plus 16c. So again, and there's nothing common inside the parentheses other than a 1, so I can't take anything more out to make this number out here larger.
It was that factoring as well?
Sorry?
Was that just factoring as well?
I'm sorry, but I'm hearing a child screaming at the same time or talking, so let's try it again, Paula.
Was that factoring as well?
Was that, factoring, that's the word I wasn't getting. Yes, this was basically taking out the greatest common factor.
Okay, thank you.
Yeah, this whole chapter is about factoring. And cheers came up from the crowd, or not. Okay. Let's see, what about this one? Negative 25 x to the 5th y to the 7th plus 75 x cubed y squared. Well, can you see that this is in descending powers? The largest power of x is first, the largest power of y is first. Since our leading coefficient is negative, we're going to factor out a negative. So I'm going to take out a negative 25 x cubed y squared. Left over, I'm going to have x squared y to the 5th minus 3. let's see, that's going to give me negative 25 x to the 5th y to the 7th plus 75 x cubed y squared, right? Questions there? Recall that x, let's see, x cubed times x squared is x to the 5th, right? Or y squared times y to the 5th is y to the 7th. When you're multiplying two powers with the same base, you add the exponents. That goes back to chapter 5 if you need to review that. Chapter 5.2, 5.1 and 5.2, it talks about that. Okay, let's see here. Negative 3x plus 8. Is there anything we could factor out there?
No.
We could take out a negative.
Yeah.
All right. Let's see here. 4a squared b plus 12a squared minus 8ab minus 24a. Well, let's see. Standard form's kind of confusing here because we've got a squareds and then a's, but we've also got a b. And let's just see if it works like it is. Let's find out. Okay, so greatest common factor here would be what? 4a squared. So we'd have b plus 3. So then I'd need b plus 3 over here. Can I make that work? Let's see, negative 8a, that would give me negative 8ab. Yep, it works. So then I'm going to take out b plus 3 from there and have 4a squared minus 8a. Oh, but you know what? This isn't correct. There's something I missed at the very beginning that I could have taken out. And why do I see that? Because right here I'm going, oh, I could take a 4 out of that. So if I continued from there, I'd have b plus 3 and then a 4 and then an a squared minus, oh, wait a minute, wait. I could also take out an a, couldn't I? Oh man, I really messed that one up. So let's go back. Let's erase all this and let's go back. I was so focused on taking out or factoring by grouping that I missed what I could have done in the first place. And that is there a greatest common factor of all things? And it's better to take it out up front because otherwise you may forget. Well, let's see. I think every term up there has a 4 and an a as a greatest common factor. Do you see that? So this would give me ab plus 3a minus 2b minus 6a. Now, if I've done that correctly, what's inside the parentheses shouldn't have any common factors other than a 1. Okay, now I'm going to take what's inside and use factoring by grouping. So I'm going to switch over to brackets. AB plus 3a, what's the greatest common factor? A. Leftovers, b plus 3. Over here are my leftovers, b plus 3. Well, let's see if, oh,
Isn't the 6a just supposed to be a 6? The negative 6a.
Right here. Yeah, it is. That's where I messed up. Good job. Good job. So, yeah, now does it work? What do I take out? What's going to go right in here?
-2.
Yeah. Yeah, so if something isn't working, look and see if you made a mistake like I did. Okay. So now I've got the 4a from the outside. I'm going to take out the b plus 3 and have an a minus 2. So that was a tricky problem, at least tricky for me. Okay. see here. Take a look at this one. X cubed plus x squared plus x plus 1. Well, that's got 4 terms in it. So I'm suspicious about grouping, because typically if we have 4 terms, we use grouping. There's no greatest common factor for all 4 terms, but if I split it up into 2 groups of 2, I'd have an x squared and an x plus 1. Over here, I'd have an x plus 1. What would go out here?
1.
And what about the sign in front of it?
Plus.
Right. So now I've got, see, I can take that out, x plus 1 and x squared plus 1. And there you have it. Again, how would you check your work? Foil it back together, x cubed plus x squared plus 1. There's that one, there's that one, there's that one, and there's that one. So even though it didn't come out in standard form when I foiled it back together, I could rearrange the terms and make it so. All righty. Well, that's all I've got for you today. So what I'm going to do now is stop the recording.